Hello, so we will talk about chapter 10 at this time, and let me share my screen with you so we can go to check about chapter 10. So chapter 10 actually is everything about group by, which I think is very interesting because group by, yeah, we can use group by to do a lot of things, and sometimes I will also use pivot table, and um, I know there are like other function or method for me to use, but mainly we will use pivot and group by. So let's start. So the first thing about group by is group by mechanics. So each group by key can take many forms and the key don't have to be all of the same type. So just to say some rules that we cannot understand it. So let's start. Okay, let's start from here. Okay, I'm sorry. Start from here. We have the basic set and then we have this data frame. So first, I want to compute the mean of data one column using labels from key one. So what should I do? Is like this. I will create this data group by and okay, I want mean. So that's how I get the mean. So for data one, for key one, there are two, yeah, A and B. So this is the result. And so that's how I do it. And also the group. So this part, we can assign it to one value, to one variable, which is, okay, called grouped. And for this grouped, we can do mean or sum up or anything. So this group variable is now a group by object. It has not actually computed anything yet, except for some intermediate data about the group key df key one. So the idea is that an object has all of the information needed to then apply some operation to each of the groups. So we can compute the mean, we can compute the sum, and so the result index has the name key one because the data frame column df key one did. So if instead we had passed multi-arrays as a list, we'd get something different. So for example, okay, right now I have two keys, key one and key two, right? So what I have here is like this, and we grouped the data using two keys, and then we can unstack that part. We can unstack, and then what we should do is so the group key in this, I mean here we can see the group keys are all serious. So although they could be any arrays of the right length. So what we are looking at is states and years. And you may say that okay, these two has no like relationship. How can I do this? But actually we can still do the group by based on these two arrays. So the grouping information is found in the same data frame as data you want to work on. In that case, you can pass column names as the group keys. So for example, what we can do here is group by key and the mean. Before what we are doing is df key one dot group by, and we will put the value here, right? But right now, if we know we have numeric columns, and then we will just put the keys here. So this is an easier way for us to do that. And so the next part we want to look at is iterating over groups. So the group by object supports iteration, generating a sequence of two tuples containing a group name along with a chunk of data. So how to understand this for name? See, for name, we have this key K1, in the group, we have the result. And also, if we have two key, then this is what we can get. So the next part we want to look at is, so these pieces, we can choose to do whatever we want with the pieces of data. So we may find it's useful is computing a dictionary of the data pieces as one line, one linear, one liner. So for example, we have, we actually turn this group by result into dictionary, and we want the pieces B, then we can just easily to get this out. So by default, group by groups on axis is equal to 0. We can group on any of other axes. For example, we could group the columns of our example df here by d type like so. So this is d types, and we have grouped. So we grouped d types. So what is the result? Let's check. What's d type? Floats. And what is group? So when we grouped float, this is the result. When we group the object, and this is the result. See, so selecting a column or subset of columns. Okay, so here is how we create this grouped variable, and so create from a data frame with a column name or array of column names has the effect of column subsetting for aggregation, and so these two, they are the same, and so the objects, so for large data sets, it may be desirable to aggregate only a few columns. For example, in the preceding data set, compute means for just the data 2 column and get the result as a data frame. We can write like this. So we have two keys and we have one numeric variable. And the object returned by this index operation is a grouped data frame if a list or array is passed on sparsed or a grouped series if only a single column name is passed as a scalar. So yeah, for example, we have this data frame and okay. So next part is grouping with dictionaries and series. Right now we have this data frame, and we add some part of this data frame, and we have a mapping, and then we will do a group by using mapping, because A, B, C, D, E actually is equal to like red, blue, or orange, these colors. So that's how we get the result. And what we can do is, okay, we have this map series. We can also group by map series and do a count. So we have the same, we have the result, same result. Actually, if you change something, count here, okay, we have the same result. So grouping with functions is using Python functions is a more generic way of defining a group mapping compared with a dictionary or series. Any function passed as a group key will be called once per index value, with the return values being used as a group values. So consider the example data frame from the previous section, which is people, and which has the people's first names as index values. Suppose we want to group by length of the names. Well, we could compute an array of string lengths. So what should we do? Okay, we will group by length of the people's. So this is the index, and we group by length, and we sum them together. This is the result we have. And if we have a key list, so for key list, this is mixing function with arrays, dictionaries, or series is not a problem. And we can create it, convert it to arrays. So if we add the key list, we will add something here and to do the group by to find the minimum value. So for example, for the character 3, this is 3, right? The length of this is 3, and so what we should do is, okay, here 1, we get the minimum. Okay, so we have this one, and this one, and then we want the minimum of 1. So if this is 1, 1, 1, 2, 2, 1, 1, 1, so this is 1, 1, and get the minimum. Okay. So we can see we can get the minimum here. Yeah. So the next part is grouping by index levels. So a final convenience for the multi-indexed dataset is ability to aggregate using one of the levels. So here is an example. Yeah, we have two index here. So let me put in dot index. This is an index, and so we can group by city. Yeah, we can group by this. So to group by level, pass a level number or name using this level keyword. And the next thing we will look at is data aggregation. So aggregations refer to any data transformation that produces scalar values from arrays. The preceding examples have used several of them, including mean, count, minimum, and sum. We may wonder what's going on when we invoke mean on a group by object. Many common aggregations, such as those found in table 10.1, actually, so table 10.1 is on the book, so there are many function names that count some mean, median, standard deviation, variance, minimum, max, product, and first, last. So we can use aggregations of our own, like we can call any method that is also defined on the grouped object. So we have done like mean and sum before, right? But then what we can do is that, okay, we can get the quantile. Actually, we can find the quantile. We can find even the range of each group, and we can use group description. So here, see, we get the quantile, and we can use this one to put this function in. So the next part we will look at is column-wise and multiple function application. So here we create a new columns, a new column tape percentage, and then we group by day and smoker. Day and smoker here. Okay, so what is the result? Looks like grouped Let me check this one. So grouped dot mean. Can we get anything? Yeah, day smoker and okay, we get the mean. So right now grouped percentage is equal to grouped. So in grouped we have this column and so we aggregate the mean of this column. Actually, it's like this. They are the same. So when I use mean, we can see, okay, the result is same as here, but this is just to pick just one column. And then we can, another thing we can do is find both minimum, standard deviation, and the range for just one column. See? And we can also use it to apply for all of the, this must be a very large, yeah, table. And we can also do for some, yeah, we can like change the name of the columns, the result columns. And okay, so that's how we use this to get to calculate different aggregation results for the group by. Okay, so that's all about this thing. And also another thing we will look at is a list of tuples with custom names can be passed. So we have tuples. So what's this tuples looks like? Okay. And we grouped, aggregate the tuples. So here is the result. We have, okay, the first one, which is mean, and second one, which is variation, right? So the next part that we will look at is, okay, for tip, we have NP, which is max, which is sum. For this column, we have all of this, but for size, we only do the sum up. Okay, so the next part we will look at is returning aggregated data without row indexes. So in all of the examples up until now, the aggregated data comes back with an index potentially hierarchical composed from unique group key combinations, since this isn't always desirable. So we can disable this behavior in most cases by passing as index is equal to false. So what will it looks like? So if we didn't do that, what will it looks like? Okay, see, so this is more desirable. And the next thing we will talk about is, okay, so how to, so we have part 3 and part 4. So let's look at it. So for part 3, which apply general split, apply combine. So we have, so returning to this tipping data set before, we want to select the top 5 tip percentage values by group. First, we write a function that selects the rows with the largest values in particular column. Okay, tip percentage, so we get the highest ones, and then group by smoker, by this, and then we apply top. So when we apply top, so we get the result. The top function is called on each row group from the data frame, and then results are glued together using pandas concat. Labeling the pieces with group names, the result therefore has a multi-index whose inner level contains index from the original data frame. So if we pass a function to apply that takes other arguments or keywords, we can pass these after the function. So the next thing we will look at is, okay, we want to recall the describe thing here. And so inside group by, when we invoke a method like describe, it's actually just a shortcut for this one. So the next thing we will look at about is suppressing the group keys. So in the preceding example, we see the resulting object has a multi-index formed from the group keys along with the indexes of each piece of the original object. We can disable this by passing group keys is equal to false to group by. So this is tips group by smoker. And then we apply top to it, and we can see the result. We don't have keys anymore. Then if we don't do the group keys is equal to false, so what will be the result? Let's look at, okay, this is the result with the group keys. And then we can look at quantile and bucket analysis. So we may Pandas has some tools like cut and qcut for slicing data up into buckets with the bins of our so combine these functions with group by makes it convenient to perform bucket or quantile analysis on the data set. So what we can do here is, okay, we have quantiles and we have group by. So we will group by quantiles and apply get stats and do on stack. So which is easy to get the quantile group aggregation result. And so the categorical object returned by cut can be passed directly to group by, so we could compute a set of statistics for the data 2 column like this. I mean, this is the data 2 columns like this. And these were equal length buckets. To compute equal size buckets based on the sample quantiles, we can use qcut. And then we will pass label is equal to false to just get a quantile numbers. So this is just quantile numbers, and we set labels is to false. We cannot see anything, but if we just leave there, we will see this. So the example is filling missing values with group specific values. So when clean up missing data, in some cases, we will replace data observations using job NA, but in others, we may want to impute null values using a fixed value or some value derived from the data. So fill NA is the right tool to use. For example, we fill NA values with the mean. And so this is the data, and so if we need to fill value to vary by group, one way to do this is to group the data and use apply with a function that calls fill NA on each data chunk. So here we run it, and we have each group's mean, and then what we do is to Okay. So the syntax is here. Produce a list of containing 4 copies of the elements in East, adding these together, merge them, and let's set, we can set some values in the data to be missing. This is what we do. So I will show you what's in here. So this is data, original data thing. And this is, let me show what is group key. So this is group key. This is the data after we assign some null values, and then we get data group by, we got the mean in each group, right? And we can fill in a values using a group means like so. So fill mean and lambda, then we can fill it by this. So see, right now we fill in the Vermont and with East and Nevada and Idaho with this number. So this is how we use group by, help us to fill the mean by the data in each group. In other case, we may have predefined few values in our code that vary by group. Since the groups have a name attribute set internally, we can use that. So it's said that we have some numbers that we can assign to it. So there is another example with random sampling and permutation. So suppose, okay, I think I can finish this chapter in a short time. So yeah, let's continue. So suppose we wanted to draw a random sample from large data set, like for Monte Carlo simulation purpose or some other application. There are a number of ways to perform the draws. So to demonstrate that, we can use, for example, here's a way to construct a deck of cards. So we have, so what's in deck? Let's check. Okay, there are 52 cards, right? And this is heart, this is diamond, heart, diamond, and clubs and spades. Yeah. So now we have a series of lengths 52 cards. And and what we will do is so we want to draw the number, draw 5 cards every time. See, so the result is different for every time. Every time we get a different result. And then what we should do next is we want 2 random cards from each suit, because the suit is the last character of each card name. So we can group based on this and use apply. We can also write it like this. So this is a result we have, and yeah, so that's how we do this. And the next part we will look at is group weighted average and correlation. So we have this data frame, and group weighted average by category will then be like this. And so what we do is actually operations between columns in a data frame or 2 series, such as a group weighted average, are possible. So as another example, we consider a financial data set obtained from Yahoo, And then this is what we get. Okay, we get a cos px. Let's see what's in there. Okay, we have we have 4 columns, right? So one task of interest might be compute a data frame consisting of yearly correlations of daily returns with SPX. So how we do it? Okay, we have this lambda and we drop an A, and then we do the group by year. So we group these percent changes by year, which can be extracted from each row label with one line function that returns the year attribute of each date time label. So we could also compute the inter-column correlations. So here is how we compute the annual correlation between Apple and Microsoft. So here is another example, which is we can use GroupBy to perform more complex group-wise statistical analysis. So, for example, we can define the following regress function. So here, okay, this is the regress function, and we can apply the function and get what we want. So to run a yearly linear regression of a Apple on SPX returns, we get this result we want. And so the last part is pivot tables and cross tabulation. So a pivot table is data summarization tool frequently found in spreadsheets program and other data analysis software, for example, Excel. It aggregates a table of data by one or more keys, arranging the data in a rectangle with some of the group keys along the rows and some along the columns. Pivot tables in Python with pandas are made possible through the GroupBy facility described in this chapter, combined with reshape operations utilizing multi-indexing. So data frame has a pivot table method, and there is also a top-level pandas pivot table function in addition to providing convenience interface to GroupBy. Pivot table can add partial totals, also known as margins. So what we can do is that, okay, we have pivot table and the index is day and the smoker. And what we have is, so the default type actually is means. So here is the means. So it should be the same as GroupBy, like, okay. Group by what? These 2 columns and then dot mean. Okay. So we have total bill, we have tip. Actually, these 2 should be the same. And then we have, okay, we have an index and we have the columns. We have columns, which is smoker. And then we have the values. Actually, this should be like values. So we can make it clear, right? And we can have margins. And we can also change the aggregation function here and fill the value with NA, fill something we don't have with NA. So this is how we use the pivot table. So It's very useful sometimes, but it's not as useful as group by, because yeah, we talk a lot about how to use group by scenarios that we can use group by, but for pivot, it's only can use in a very narrow like area. So the next thing we will look at is cross tabulations, cross tab. So cross tabulation is a special case of pivot table that computes group frequencies. So we have this data, okay, what it looks like, and we do the cross tab. So cross tab actually is doing count, just doing count. So for example, for Japan, okay, Japan right here, left-handed, 1, 2, just 2. So this is how it gets the number. And we do tips time, tips day, tips smoker. Let's see the result. So we can see that if we use cross table, what we can get actually is frequencies, which is count. So there is only one aggregate result we can get. So that's all about chapter 10. And so see you in next video.